Hey everybody, this is Games Plus James, and welcome back to our Unity 3D platformer tutorial series. So in the last episode, we set up a way for our player to get hurt when he runs into any objects that can do damage. At the moment though, it doesn't look very obvious in our game that our player is getting damaged. We can see on our little countdown thing up here that our current health, we're taking damage whenever we hit against the object, but there's no visual feedback within our world. So let's add some little knockback to our player. So whenever they run into an object, they get knocked back away from it. So I'm going to stop that running here. The way we're going to do this is on our player, essentially what we'll do is we'll decide how much force we should add to the player to knock him back. And then we'll say, okay, for a certain amount of time, our player can no longer move. So we can't control the player for a short amount of time. They get knocked backwards, and then we can move forward and continue moving within the world once the little knockback amount has happened. So what we'll do is go to our player controller. As I said, we're going to need the amount of force that's going to push us back. So we'll create a public float called knockback force. We'll need to know how long we should be knocked backwards for. So we'll say public float knockback time. So that's going to be how much time we get knocked back for. And then finally we'll have a private float called knockback counter. Oh, no, that should be private, and that should not be capital A. So our knockback counter is basically going to be the value that we use to control whether we're being knocked back at the moment and how much longer we should be knocked back for. So to manage our knockbacks in general, we're going to create a new function down here that we're going to say public void knockback, like this. And so this is going to be the function that we call that will knock our player backward within the world. So whenever we want to knock back our player, first thing we're going to need to do is set our knockback counter to be equal to whatever our knockback time is. So how much time we're going to get knocked back for. And then we'll need to apply what movement should actually happen to our player. We'll look at that in a second. But before we do that, now that we're setting our knockback counter to be equal to our knockback time, let's say, okay, we know that for however long this counter lasts for, we want our player to not be moving. So first thing to do is make our knockback counter count downwards. So I'm going to do that. Actually, no, we'll do that second. First thing we'll do is do a check up here to say if our knockback counter is less than 0. So what we're saying here is if our knockback counter is less than or equal to 0, so basically if we're currently not being knocked back, then we want to put our open bracket here, and we're going to close this bracket after all this input stuff has happened. So we don't want to be able to jump the player or anything like this, which is also our jump little function here is also making sure that our move direction stays at 0 when we're on the ground. We don't want to have that coming into effect at all when we get knocked back. So we're going to put a close bracket just there like this. So this whole section only gets called if our knockback counter is 0 or less. So we're going to add a little else here. And basically what we're saying is if our knockback counter is 0 or less, then move around as we normally would. Otherwise, we want to make our knockback counter count down. So we'll say knockback counter minus equals time.delta time. So it's counting downwards. And if our knockback counter is counting downwards, then that's all we need to do. We don't want to be able to do any input or anything like that, so we just let the only directional stuff that will still happen is whatever gravity we have applying to the player. So we want our player to still work within the laws of physics in regards to that. So we can save that now, just to make sure we're saving as we go. So if we know now that we are stopping the player moving whenever our knockback counter is set up, and we have our knockback counter counting down, that's perfect. Let's just test that out within the game. If we let go back in here, go to our player object within the world here, And we're going to say, it doesn't matter what knockback force we set for now, but knockback time, we'll set this at, we'll just set it at 1 second. That's a little bit too high, to be honest, but we'll just set it for movement reasons. So I'm going to run towards this cactus, and I'm going to keep pressing up the whole way. Oh, well, that didn't actually do what we wanted. Oh, because of course, at the moment, because we're going towards the cactus with our force pushing us forward, that force is still being applied because we're not applying any new force with a knockback yet. So if I run towards it and say, if I hit the object and try to press right, it takes a little bit longer for our input to actually register. So it's kind of hard to see what's actually going on here. So let's take a look at actually knocking the player back the way we want them to. So I'll go back to our script. And basically within here, what we want to do is apply a direction that our player should move in. So on our public void knockback here, we're going to take in a value, a vector tree that we're going to call direction, like that. Oh, we don't need the semicolons. And what we'll do is say our move direction that we use to move around with our controller, we're going to set that to be equal to whatever direction gets passed in. So this will be the direction that we should be knocked back in. And we're going to multiply that by our knockback force. And just for the purposes of testing this out, I'm going to say just here, direction equals a new vector tree 1, 1, 1. So what I'll do is I'll just take that direction that we're applying, which is our 1, 1, 1. So that's just left, or sorry, no, it'll be on the x-axis right, on the z-axis forward, and on the y-axis up. And then it'll multiply that by whatever our knockback force value is. So let's save this. Go back into Unity again. This time we're going to set our knockback force to be, we'll set it to be 20. So it's a good amount of force. And now if we run towards the object, oh, we're not getting that called at all. Oh, of course. I'm just realizing I haven't actually set it up so that doing the damage actually calls our knockback. So let's set that up first so we can actually make this happen. I just realized it's not magically going to work just by hoping and wishing. We actually need to modify our scripts to be able to run it. So what we'll do is we'll go to our health manager script, and where we have our hurt player here, we want to call the knockback effect on our player within the world. Because if we go to our hurt player script, what we could do is go in here and do another find object of type player and use that to hurt the player. But there's no real need to do that. We don't want to do multiple find objects of type whatever, because they can be a slightly intensive in terms of computation time within the computer. So we don't want to do multiple ones at the same time. We might as well, because we know that our health manager, this script is always going to try and hurt the player. So we only have one health manager within the world, so we might as well offload that to the health manager. So that can do one call at the very start. So we can do public player controller that we'll call the player, and within our health manager we can just find the player once, and then we know we'll always be able to access it. So we can just say here the player equals find object of type player controller. So we put that within our start function so that as soon as the game starts, our health manager will always know where the player is. So then within the hurt player script here, we can call the player dot knockback. So we can knock back the player, but if we want to knock back the player, we need to know what direction we're going to move it in. And to know what direction we're going to move it in, well, that's only going to be told to us by the hurt player object. So we're going to take in here on our hurt player function, not just the damage amount that we want to do, but also the direction that we should knock the player in. So this should be a vector tree called direction, and then on the player.knockback we can pass in whatever direction is given to us in the hurt player function, we can pass that on into the player controller script. So that's fine. The logic of that all makes perfect sense. So let's go back to our hurt player here. And here now we've got a little bit of an error because we're only giving it the damage amount. We're not actually giving it how much we want it to move within the world. So to work out the direction of our movement, basically all we do is we'll create a new vector tree. So a vector tree that we'll call hit direction. And we can work out the hit direction by just saying, okay, the other object that just ran into us, so the other dot transform dot position, which is the player, all we have to do is take away whatever our current transform position is, so transform dot position, and the difference between those two objects will be the direction that the player actually came, or the direction that the player is away from the object. Now we don't want that to be having a crazy excessive value. We want to limit that so it can only be at the most. It could be, say, 1 on the x-axis or 1 on the z-axis or 1 on the y-axis for how far away the player is above us. And the way we do that is just by saying our hit direction equals hit direction dot normalized. And basically normalized essentially restricts it to being within a straight line distance in whatever radius it is around the object at the center. And it's just a way of basically ensuring that we'll get consistent knockbacks at all time. So now that we've worked out what direction the player is in, we can pass that in to our hurt player function. So we can say hit direction is what we'll use as well as our damage to give. So we can save that. So what will happen is our player will get hit. It'll work out what direction it was hit from. Or the cactus will work out which direction it was hit from. Then it'll go to the help manager. It'll tell it, okay, do this damage and this is the direction that we want to give you. Then it'll go to the help manager and it'll take away the damage and it'll try to knock back the player in that direction. Of course, we're not actually doing anything with that at the moment. If we go back to our player controller script, at the moment we're just demonstrating it in a static direction. So we'll just go back in here into Unity and press play. And now if we run, hit the object, there we go flying away like a maniac. Like I said, the length of time on our knockback is a little bit long at the moment, but you can see it is working for us. So let's now take the actual direction that's being given to us and apply it to our player. So we can, instead of setting our direction to be 1 1 1, we can just completely delete that line. We don't need that anymore. So now we've got our move direction being applied just where we want, and our players moving around within the world. So we can save this, save it, there we go, and go back into Unity, let that compile, and now if we run and hit play, there we go, we can see our player is being knocked back like a maniac. But there's one little thing, actually just before we go on, that knockback site length is a little bit too long. I'm just going to put this to 0.25 so it's a bit more sensible. So there we go, our player gets knocked away from whatever object it is. But you can see what's happening is our player is getting knocked back on the ground, which isn't really what we want to happen. If I jump on top here, you see we get bounced away like that. So if we're higher than the object, we'll get knocked up in the air. But if we're on the same level as the object, which is what's happening here, we run into it and we just get knocked back along the ground. So we don't want that happening at all. What we want to do is whenever we get knocked up, no matter what, we want our player to get knocked up into the air at the same time. So what we'll do very simply there is, okay, so we're setting our move direction to be whatever direction came into our object. Well, we want to make sure that no matter what, we get knocked up into the air. So we can just here say our move direction dot y should be equal to our knockback force. So no matter what, we're going to get knocked up into the air. Save that. Go back in. And once it compiles, we should see our knockback working just the way we want. So we get hit. There we go. We get sent up into the air. Oh no. We've been hurt and we're flying away. So I think that's probably even a little bit too strong with our knockback there. So we'll do this. There we go. We get knockback. We get knocked away just enough before control gets returned to us. We can see we get knocked away just like that. So perfect. We've got our knockback all working just the way we wanted to within the game. Nice and handy. So now that we have our knockback, let's actually make it a little bit more visible for the player as well, and make a kind of effect that makes it look like our player is being damaged. So we're going to take a look at adding a little bit of invincibility to our player in the next episode. So we'll be able to see, hey, look, we've just taken damage, and also in the next amount of time, we won't take any more damage. Because just for example, we'll just pop back in here for a second. I'm going to grab this cactus. I'm going to duplicate it. And we'll create a couple of them here. And at the moment, if we were to run into the middle of this little pack here, if we hit off one, we'll hit multiples, and we'll take a whole bunch of damage every time. So even though I've only technically run into one object there, if we go to our game manager, we can see our current health. Sorry, I ran into 3 separate occasions there. But if we watch our current health, if I bounce off one, there we go. I've taken 2 bits of damage for 1 impact. And that's not what we want at all. We're taking too much damage. So we want to make our player just invincible for a tiny, tiny little fraction of time so that they don't take any extra damage than what they initially caused themselves. So we're going to take a look at doing that in the next episode.